Smart Monitoring Hydroponic System. First of all, I would like to introduce our supervisor, Mr. Karizan. Additionally, we have Mr. Safawi, an esteemed advisor specializing in hydroponic. Now, I'm going to talk about our project overview. I break down the overview into 3 points, and the first point is soil-free cultivation. The hydroponics project innovated plant growth by eliminating soil, relying on the deep flow technique where the plant's roots are immersed in a nutrient-enriched water. Second point is Raspberry Pi integration. Utilizing Raspberry Pi 3B Plus as a core component, the project established connectivity with the various sensors and devices and monitoring by growers. The third point is data visualizations via Blink server. Important data such as temperature, humidity, pH, and nutrient use are systematically recorded and displayed via Blink server, empowering growers to evaluate and monitoring their cultivation. Problem statement. The first problem statement is it holds significant importance to closely observe and address the specific requirements of plants. Second is meeting the plant's need within certain time frames is crucial. Third is existing method within hydroponic system impose restrictions that impede achieving the best possible plant's growth and output. Objective. First objective is to study the integration between smart agriculture with IoT. The second is to develop a precise nutrient management system to customize fertilizer application. Our project scope. First project scope is to present the accurate data on the dashboard for monitoring purpose. Second is utilizing the microcomputer for the development of this project. The third scope is integrate sensor technology into agriculture practice for enhanced efficiencies and precisions.
Literature review chapter provides an overview of relevant research in the field of hydroponic monitoring system. Irawati Ramadan and Hadioso from 2022 present the use of Google Firebase for real-time data storage and retrieval in enabling IoT-based monitoring and control of hydroponic system. Also, Eastwood, Ayer, Nettle and Delarue from 2019 focus on employing the Node MCU ESP8266 microcontroller as the central component in their indoor hydroponic farming system for monitoring and data collection. For our project, we diverse by utilizing the Raspberry Pi 3B Plus as the central component and Blink Cloud for real data storage and retrieval, leveraging their capabilities for processing and connectivity.
Methodology. For the workflow, we start with the brainstorming, which is find the problem, objective and scope. Next, we go through to the literature review on the project background and find the tools and technique, and last, previous study. Next, methodology, find the data gathering and analysis, approach and method use, concept analyze, design and development stage, preliminary result, principal operation, components and costing. After that, we discuss the result. If the result is not satisfied, we will redesign again starting from the methodology until we get the final result, until we certify the result. For the flowchart, we start with the microcomputer installation. The microcomputer will reading sensor value, and we got the 3 sensor, which is easy sensor, pH sensor and temperature sensor. Easy sensor will balancing the measure that should be according to the ppm reading, same like temperature sensor. Temperature sensor will balancing to and measure that should be according to the ppm reading. For the pH sensor will send the sensor action to database and display the sensor action on the dashboard if the sensor value threshold limit, and the notification will be sent to the owner. For the watering will be run in 24 hours, same like spectrum LED glow light. We go to the plot diagram. In plot diagram, we can see that TDS sensor, pH sensor and temperature sensor will send the sensor value to Raspberry Pi 3. After that, Raspberry Pi will send the sensor value to the database and display on the dashboard. Raspberry Pi will send the notification if the sensor value threshold the limit and open the fertilizer if the ppm is low. This is bill of equipment that we spend to finish the projects. And the final total price is RM 977.87.
Microcontroller platform comparison. The first aspect that we compare is the computing power. For Raspberry Pi, there is high processing power with CPU, RAM and GPU. But for Arduino, there is limited processing power with microcontroller. But for Node MCU, moderate processing capability with integrated Wi-Fi. Next aspect is operating system. For Raspberry Pi is around full pitch OS, which is Linux based. But for both Arduino and Node MCU is no operating system. For the next aspect is connectivity. For Raspberry Pi and Node MCU, they both have integration Wi-Fi for IoT. But for Raspberry Pi, they have multiple USB and also have HDMI. For the next aspect is GPIO pin. For Raspberry Pi, GPIO pin available for hardware interfacing. But for Arduino is dedicating I/O pin for hardware interfacing. And for Node MCU is GPIO pin for hardware interfacing.
In the realm of hydroponic monitoring system, selecting the appropriate database solution is vital. Dropbox offers general file storage without specific IoT functionalities, while ThinkSpeak provides IoT-focused features like data visualization and basic analysis using MATLAB, albeit with server dependency. Blink excels in user interface design with its drag-and-drop interface and real-time control capabilities, making it a preferred choice for our hydroponic farming project. The decision to opt for Blink was driven by its user-friendly interface, which aligns seamlessly with our need for intuitive operation and customization. Additionally, Blink's real-time control capabilities enable swift monitoring and adjustment of parameters, ensuring optimal plant growth condition. Despite its reliance on Blink servers, the platform's robust features and integration capabilities make it the ideal database solution for our smart monitoring hydroponic system, enhancing overall efficiency and functionality.
Project sketch. For the project sketch, we got the TDS sensor and pH sensor on the water, and we got the water pump to make a water flow, and the DHT sensor will be outside to read the temperature of the surrounding area. We also use mini peristatics to put fertilizer into the tank, and we use 2-inch polystrings and net pot as a raft, and the monitor as a dashboard.
Project circuit. As we can see in the slide, that was the picture of our project circuit diagram that we are using for our project, containing 3 sensors, which are TDS sensor, DHT sensors and pH sensors. For TDS and pH sensors, they both are analog output, so there is required ADC to convert them the output to digital output. For that, we are using the MCP 3008. For the pump, we are using peristatic pump, and the pump itself cannot directly connect to the Raspberry Pi, so we are using the relay module to make the connectivity happen.
For the result, we also got the sensor action result, which is the message warning works based on the received sensor readings, while a notification will be sent if the sensor value is not encouraging. In addition, if the sensor reading indicates that the plants lack fertilizer, the mini peristatic pump will drain the fertilizer from the depth of the water tank. In conclusion, our smart hydroponic monitoring system using Blink Cloud Server is a game changer for hydroponic crop productions. It is user-friendly, provides real-time data, and lets you monitor things from your phones. This is not just for big farm, it's perfect for home gardens, precision farming, greenhouses, and even educations, by making things easier and more efficient. Our system is a step towards a smarter and more suitable way of growing crops.